For today's lesson, we're going to discuss about significant figures. Significant figures, or also known as significant digits, are all the digits that carry meaning in a number. They are only relevant with measured values. It shows how precise the value is. For example, the tallest person in the world was about 3 meters tall. The tallest person in the world was 2.72 meters tall. The first example has 1 significant digit, while the second one has 3 significant digits. It only shows that the second one is more precise. Non-zero numbers are always significant. For example, 243 has 3 significant digits, 5 has 1 significant digit, and 23,439 has 5 significant digits. Placeholder zeros. Zeros at the beginning or end of a number are not significant. They simply tell us the place value of the number. For example, 100,000. It has 1 significant digit. The 5 zeros are not significant because they are just a placeholder zeros. 0.001 also have 1 significant digit. The first 3 zeros are not significant. Middle zeros. Zeros between non-zero numbers are always significant. For example, 101. It has 3 significant digits. 2.001. It has 4 significant digits. 50,300. It has 3 significant digits. Because the 3 zeros at the end are placeholder zeros. Zeros in a decimal. Zeros after the decimal and non-zero numbers are always significant. These zeros indicate a more precise value. For example, 0.10. It has 2 significant digits. 2.00 has 3 significant digits. 0.00340 has 3 significant digits. The first 3 zeros are placeholder zeros. Another way of finding the number of significant digits is using the Atlantic-Pacific rule. In Atlantic-Pacific rule, we need to remember the position of North America. On the left side of North America, you will find the Pacific Ocean. And on the right side of America, you will find Atlantic Ocean. So all you need to do is to remember the first letter of these oceans. P will stand for present, while A will stand for absent. So what we need to look for is the decimal point. If the decimal point is present, it means we're going to start counting from the left. If the decimal point is absent, we're going to start counting from the right. Now, what do we need to count? We're going to count from the first non-zero number. For example, 243. In 243, the decimal point is absent. So we're going to start counting from the right. So from the right, we will start counting with the first non-zero. So this is our first non-zero, so that will be 1, 2, and 3. So it means we have 3 significant digits. Second example, 0.001. So our decimal point is present. So it means we're going to start counting from the left. So remember, we will start counting the first non-zero. This is 0, so not counted, not counted, not counted. So this is our significant digit. So it means we have 1 significant digit. Third example, 2.001. Again, the decimal point is present, so we will start to the left. First non-zero. This is non-zero, so we will count 1 and everything else will follow. 3, 4. So it means we have 4 significant digits. Next example, 101. The decimal point is absent, so it means we're going to start counting from the right. First non-zero, so this is our first non-zero, so we will count it. 1, 2, 3. So it means we have 3 significant digits. Last example, 0.00304. Again, decimal point is present, so we're going to start counting from the left. Remember, we will count only the non-zero. This is 0, this is 0, this is 0, and this is non-zero. So 1, 2, 3. So we have 3 significant digits. Exact numbers. Some numbers are exact because they are known with complete certainty. Exact numbers are counting up how many of something are present. They are not measurements made with instruments. Therefore, if a number is exact, it does not affect the accuracy of our calculation nor the precision of the expression. For example, number of days, number of years, the number of moons, or the number of planets. They are all exact numbers. Significant digit rules, multiplication and division. When you multiply or divide, the final answer must have the same number of significant digits as the value with the least number of significant digits. Remember that exact quantities don't count. For example, 13 multiplied by 20. 13 has 2 significant digits, while 20 has 1 significant digits. So we're going to follow the least, which is 1. 13 multiplied by 20 is 260. 260 has 2 significant digits. To make it 1, we need to round it off, so it will become 300. Next, 248 divided by 23. The answer is 10.78. 248 has 3 significant digits. 23 has 2 significant digits, and our answer has 4 significant digits. Remember that we need to follow the least one, so it means 10.78 need to be rounded off up to 2 significant digits, and that is 11. Last, 3,249 multiplied by 13 divided by 243. Our answer is 173.8. The significant figures given are 4, 2, and 3. And our answer has 4 significant digits. So we need to follow the least, which is 2. So to round it off, our answer will be 170. Significant digit rules, addition and subtraction. Whenever you add and subtract, the final answer must have the same number of decimal places as the value with the least number of decimal places. This time, we're talking about the decimal places, not the number of significant digits. Remember, exact quantities don't count. For example, 13.4 plus 23.45. In 13.4, we have 1 decimal place. 23.45 has 2 decimal places. The answer is 36.85 that has 2 decimal places as well. We need to follow the one with the least decimal place, and that is 1. So it means the final answer should have 1 decimal place as well. Next, 101.0 minus 4.80. The answer is 96.2. The first one has 1 decimal place. The second one has 2 decimal places. So our final answer should have 1 decimal place as well. Last, 0.3 plus 0.85 minus 0.150. The final answer is 1. But if we count the decimal places, this one has 1, this has 2, and this has 3. So we're going to follow the one with the least decimal place, which is 1. So we're going to add 1 decimal place in our final answer. That's why we get 1.0.